You toss a coin 20 times and follow the path shown in the diagram below. Is this a fair game for both player A and player B? If not, which player has an advantage? So let us, I know what to do. Let's do an expected value calculation for player A, and let's do an expected value calculation for player B. Okay, so we start the game. It's either heads or tails. There's a 1/2 probability that it's heads and a 1/2 probability that it's tails. If it's heads, A wins a point. So that would be a positive 1 point for A, multiplied by the probability of that happening, which is a 1/2. And if it's tails, we throw the coin again. All right. When we throw the coin again, there's a 1/2 probability that we'll get heads and a 1/2 probability that we'll get tails. If we get heads, player A wins a point. All right, so we're going to add a value of 1 point by the probability of this happening. Now, the probability of this happening is not a 1/2. The probability of this happening is 1/2 of 1/2. Because remember, we had to get tails in the first place to even toss this coin again. So this probability is 1/2 of 1/2, or 1/4. So that's a 1/4. The expected value for B, nothing was happening for B up here until we get to this. There's a positive value of 2 points. Player B wins 2 points if this happens. But the probability of this happening, again, is a 1/2 multiplied by a 1/2, or 1/4. All of these probabilities for the game should add up to one whole, and you see that they do. A 1/4 plus a 1/4 plus a 1/2. I mean, if we ended the game there, it'd be a 1/2 plus a 1/2 is 1, but this 1/2 gets halved again. All right, I think I'm overdoing it. This is a 1/4, 1/4, and so I'm multiplying the value. I wanted to multiply it by a 1/4, and I wrote a 1/2. Okay, so let's complete, well actually, expected value for B is easier to complete because it's 2 times a 1/4 is 2/4, it's a 1/2. Expected value of 1/2 for player B. For player A, 1 times 1/2 is a 1/2, 1 times a 1/4 is a 1/4, and a 1/2 plus a 1/4 is 3/4, because 1/2 is 2/4 plus 1 more 1/4 is 3/4. So it's better to be player A in this situation. On average, you're going to win more points as player A than player B. In fact, if we toss the coin 20 times, should I do this? Yep. Player A, we can figure out the expected number of points for player A. Every single coin toss, the value of that coin toss is 3/4 for player A. So 3/4 times 20 would result in 15 points on average for player A for those 20 tosses. The expected value for player B is 1/2. So 20 multiplied by 1/2 is 10 points. So after you toss the coin 20 times, player A should be ahead of player B by 5 points. I mean, you could actually do an experiment and use this table to assign points and see if it works out that way. Although if you do that, keep in mind what we learned about experimental probability. These values that we're pointing out here and this expected outcome is based on theory, not what will happen in an experiment. Experiment will match that theory if you toss the coin enough times. Like if you do 200, you might expect it to be closer to 150 to 100. If you only do it 20, it might not really work out that way. Okay, the problems on the learning opportunity, I think are very much like the notes, but as we've been doing, you've got things to back you up, many things. The homework help video on the blog, the 1:30 p.m. Zoom sessions, and you'll get feedback on everything. There are little videos for every single problem. So keep using those well so we can finish strong.